So yeah, I mean, dilate just means stretched. And scale factor we talked about, if it's two, they want to know, find the permanent area. Well, it's a square, obviously, right? So if you have a square, we know we multiply 19 by itself to get the area, or multiply 19 by 4 to get the perimeter, or just add up all the sides. So I know for the given square, it's going to be 76. 19 squared, I think that's, don't tell me, 361. But here's the thing. After it's stretched, right? So after it's expanded, by what factor again? Each side is multiplied by what? 2, right? So the perimeter will also increase by 2. 152. The area, however, doesn't is by 4. And I'm trying to do this in my head. 1444, I think. I mean, I could be wrong. Someone want to check me? 361 times 4.
Yeah, you're right.
Wow.
How do you do that?
I don't know. I just did.
Gutenberg.
What's the Gutenberg method?
German.
I did 36 times 4 in my head, so I got 144. Then I added 1 4 times and add, so that's what I did. So anyhow, but you guys see the idea, right? So I don't have to do another problem with this. I think you guys get it. Um, that's more the same thing. It's level 2, so it's supposed to be a little harder. Um, so in this case, they say the square below is the image of a square that was already dilated. Find the perimeter of the pre-image. So going backwards, right? So if you want to go backwards, right now this perimeter is 40. So I just got to divide by 2. I should get 20. So it's asking to go backwards. So there you go. But if it was area, then you divide by 4, obviously, right? Because you got to do the scale factor squared. Here's just more of the same stuff. So yeah, I mean, I could go through all this, but or similar figures, proportions, level 3. Quadrilateral, this is similar to that. Um, they want us to find JK. Okay. So JK lines up with what side? Yeah, correct, right. So you're gonna want to do this. You're gonna want to say, okay, cool. Um, 19 over 59. If I compare this with this, will be 30 over X. And I trust you guys can just cross multiply and work that out. So, but for those who did do this, was it okay? It was fine. How long did it take, would you say? It did? Oh, geez. It was long? Okay. 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 So then I will reduce this then. Okay. For future Delta Math science, because I put 8. Okay. That's fair. Okay. I appreciate that. So I'll probably do like maybe half or maybe 6 categories. So, okay. But good to know. Okay. All right. Let's go to the notes. Perfect. If we go to the notes. Sure, of course. Yeah, yeah. No problem. Oh, perfect. Here we go. Right folder. All right. So what we're gonna do is I'm gonna assign tasks for every table, and you guys are gonna do the calculations, and I'll guide you guys through it. And then we're gonna look. I'm gonna have people come up to the board and put their calculations up. Uh, Fortunately, I actually observed Mr. Davidson's class last period, so I'm gonna copy what he did because I like what he did.
Mr. Davidson's class get to go outside.
No, so that's why I'm making it better. I make his class better in his class. But also, we have lunch coming. Also, it's warmer now.
Yeah.
We'll-
I bet the class is better than.
oh yeah. Okay. All right. All right. Yeah. Good. All right. All right. So here we go. So if we look at 8.3.1, this is page 29 of the notes packet. So I'll read the instructions. Your teacher will assign your team several of the regular polygons below. You can see there's a total of 12 listed. This is perfect because we have 12 people in this room. So I'm going to give every table group 3. And among the table group, you guys can say, hey, you get this one, I get that one, I get that one. So each person could do 1. Um, but we're going to kind of keep them in order because there's a pattern here. So for each polygon, find the area and perimeter if the radius is 1, as shown in the diagram of the regular pentagon. Let's be accurate. Try to give your answer to the nearest 0.01. So you're going to give decimal answers. Place results in the class chart to help predict the area and perimeter of the polygon with infinitely many sides. Okay, so what does that mean is that we're going to eventually start increasing the sides by a lot, and we're going to start noticing a pattern. So really quickly, what you're going to be doing, I mean, I'm not going to actually do it because I want someone else to, I want the right person to do their own work, but you're going to draw something like this, right? Actually, that was wrong. It's not one. That's all I know. I'll call it X. So I know this, right? That's true. So how are you going to solve for X? What are you going to do? You got to do that, right? Yeah, how do I know the height? How would I get that? What would I do? Right. What's this angle going to be? How would I solve that? We did that last week. Perfect. Good. Which is 72. And if that's 72, what's this little sliver there going to be? Good. So if that's 36, how would you solve for H and X? Using SOHCAHTOA. Use trig. Yeah. You use trig to solve for X, H, and X. Once you have H and X, can you get the area of the triangle? Yeah. Can you get the area of the pentagon? Yeah. Can you get the perimeter? Yeah. Because you're gonna have all the sides. But you can see it takes a little time to go through those motions, right? So that's what you guys are gonna do. Every single shape you'll work with will have a radius of 1. Now the hexagon's a nice one because it's equilateral. We know that. The rest are not. But you do need to figure out the central angle before you move forward because you can't do these problems if you don't have the central angle, right? So here's what we'll do. The table right in front of me. So Connor, Zoe, and Cam. You'll do the first 3. You do A, B, C. How you want to divide the work, if you want to go through each one together, or hey, if Connor gets A, Zoe gets B, Cam gets C, whatever you do, I don't care. It's up to you. But this will be the first group. You guys are A, B, C. In the back, Colette, Kira, and Peter. You guys are D, E, F. And then the way back, Samega, Ale, and William, you guys get G, H, I. And the last group with Faith, Reagan, and Sabine, you get J, K, L. It's up to you guys. Okay, I'll walk and help you guys out. And if whenever you guys are done, you put on the board. I'll look for a pattern. Okay.
So what is it? Check. They were just trying to find like the area.
Correct. You got it.
The finding the radiation is the radiation of the light as in having a triangle is 1, then does that make the height 2?
Sorry, if you have what?
If the radius of the lateral triangle is 1, does that make the height 2?
No, it'll be root 3. No, it'll be root 3 over 2. But do you have a hexagon?
Or equilateral triangle.
Oh, equal. Oh, right. If it's 1, 1, 1, that also would be root 3. Right.
Can I borrow Mr. Davidson's?
Sure.
Thank you.
And by the way, your answer should be pretty close.
So let's one find the radius of the
Radius of
lateral
everything.
triangle.
Yeah. Got right. Yeah.
How does one find the radius of the lateral triangle? Like where would that?
It should be all 1. Actually, wait 1 sec. For you,
Mr. E.
I think you're gonna be doing this. Sorry, my bad, Connor. You're gonna be doing this.
Okay.
That's what you want to do. Yeah, guys, radius means from the center. So for quadrilateral or square, and all these are regular. So whoever has a square in your group, you're doing this.
Like, do like, yeah, just like find and triangle part history.
After that should be pretty smooth after that. Which one you got?
Notes, I think, set like my notes.
Yeah, I gave you the key because I didn't print the like notes.
I just, yeah.
Oh shoot, that's right. You have all the answers. Yeah, let me print you the I think because I just had it on the fly, get you something. Let me print that right now actually for you. Because you should have. Let's go. Only thing it's gonna have a bit of a smear because the copier is like kind of crappy.
One, that was it, but 5 times was 2. It was 2.
Really pick it up. I will take a while.
Wait, how are we supposed to find it? You like split it into a right triangle. And then you find like, yeah, it's like, oh. Like everyone, you just like break it into like triangles and stuff.
Let's see, maybe there's a
Thank you.
Two over two.
Yeah, that's.
Side.
no, it's odd, but what's it checked?
No,
It'd be either 8, 2.
Wait, we
over
need
2 or
G.
8, 3. 2 over 8.
Oh, so random. Okay, right. Okay, well, that's fine. That's fine. It's a G check.
Wait,
Yeah.
Okay, you're so boring.
Yeah, okay, that's fine. Yeah, yeah, I think you're fine. Yeah, yeah. Well, let me double check. I think you're fine. Yeah, you're good. Wait, you did 4 or 5?
5.
Yeah, you're good, yeah.
4 or 2 is right as well. Yeah.
For this, I got 2.
For the area, it's just 2 root 2 over 2 times root 8. It's just 5.
Okay, for area, I got 32. Mine was like 2. I did it like that, or I split it up as an X and then 21 X and 9. Okay, so
Nice impressed.
I did 1 times 1 times 1.
If anyone wants to verify the work, I could.
I haven't, Vaughn and I never. 0.
Yeah.
Look, it sounds right.
Yeah, I guess 6.24. I got my tab. It's okay. It's all right.
Where
That,
are all of the radius?
yes, very similar. Yeah. Here, take a look. You're good. You got that. Good. Yeah. Yeah, that's right. You got that. Yes.
The area.
But can you give me a decimal for that one, please? They want to see a pattern on all the numbers. Okay.
I got 8 root 2.
I'm sorry, what's right? The 4. I see my brother just.
You have an extra graph one.
No.
Don't be refused for that one. Don't be refused for that one. I'll come and help you out.
Split it like.
Oh, you got the side in this root 2. The area's gonna be 2. The side length is root 2. Show me a diagram.
Alright.
No,
it's 1.
No, that makes sense.
Yeah.
Should I get the right answer?
Okay, we'll get a calculator.
For area, or for all group, for perimeter, I got 6. And for area, I
Oh,
got.
yeah, because you're way.
Wait,
Mr.
Yeah, what's up? Yeah, which one do you got? Which one are you working on?
I'll
Yeah.
do.
Well, you guys are the ABC though, right?
Got me.
Did I give you guys ABC group?
Yeah, wait, so.
So which one are you doing, Connor?
Fine.
Which camera are you doing?
Okay,
Okay,
regular octagon.
so you do opt out for a minute. That's the whole shape.
Why are you
That's
so fun? Yeah, that's
It's cool colors.
That's
It's Bobby. There we go. See that, right?
Yeah.
Okay. Now, you have 8 triangles, of course. So they have to be split equally. That's 45 degrees. But we're gonna break it up like this.
The 22.5.
Right. And we'll call it X, we'll call it H.
Yeah.
Now you gotta use trick. Then you should be able to move it after that.
I'm confused on how you'd find
Yeah.
the like perimeter, because if this was like this is a triangle, like a 30 has.
That's way too big. So, the 30 gone, let's put it in first. So that's 6 degrees.
Oh, I put it spot for.
Remember? That's still not correct. You have 6 degrees, right? That's not from side. Do cosine 6 degrees. Let's make sure the right vote. Did you right vote? Okay, cosine 6 times 1. So that's 0.999, right? Then I do sine 6. It's 0.104.
Oh,
It's way smaller. It's not 0.5.
so it's not like lateral.
No, it's not. No, because it's 6 degrees.
Oh,
Yeah. Yeah, correct. Yeah.
Wait, and then what's the base?
So you actually be much, much smaller. That's why your answer's off.
That's right.
By the way, once you solve for one of the sides of the right triangle,
0.0.
you guys could use Pythagoras to figure out the other side too, just so you know.
Oh, yeah.
So we'll check.
The height is what.
It's okay, it's 6.3, right?
That's okay. I'm okay with that.
0.0.
Would you have 15, Dave? Yeah, that's fine. It's a tad off. It should be, okay. Your angles are off, that's why. Okay, so this is actually 120 degrees. So when you split, that's actually 60 degrees. And if that side's 1, then this side's 1/2, that side's √3 or 2. I mean, if I use it by ratios. So the triangle is going to be √3. And that's 1/2. Doing 1/2 times your base times your height.
Right.
So it's √4. And you got 3 of them. So now it's something that's it. You can use trig also, but I decided to do the ratio. So 3 √3. And divide that by 4. Okay, that's it. That's what you should get for your area. And the perimeter is going to be √3 times √3 times √3. Or sorry, √3 plus √3 plus √3. Well, 3 √3. Correct. That's what you should be getting. Yeah, if you guys want to come verify your work. Very good. Yeah, that's very reasonable. Good. So we're gonna put these up in a moment. Always. So 2 degrees. If you're in 2 degrees, the H to be go a little further out. That's my what's off. Yeah, try putting more decimals. That's way too rough.
What'd you get for
approximation.
For half or for the whole thing?
Okay,
20.
for those who are done,
This is a high.
you want to put them up on the board. I brought the markers. Yeah, there's my markers. Yeah. So. 4 minutes like that. Yeah.
They're just random now.
Yeah. Next to the ones that so look for patterns and I'll show you the correct answers.
Mystery, if I feel like, if I give it another decimal place, it just keeps going down. I don't know what we did wrong.
Why not since we're
The tangent, the first one, whatever. The tangent of fuel equals x if you want. And the base is fuel. We have the fuel base. And the by 90. Yeah, we should have. That's for the perimeter. And then for the area.
That's the perimeter.
That's the perimeter, I think it's 6.29. Now. For excuse me. For area, I don't know. And volume, I have no clue either. That's your base, what happens to the base, times your height. The height would be, wait.
Yeah, I don't know.
Let's see. So society.
Really do.
Let's go. We'll say then 8.5 times that. Times the highest can be the cosine. Of 2.
Actually,
And then times that by, we have, 90 triangles. Wait, no. Yeah, no, you're right, yeah, you're right, okay. There we go.
Yeah.
Right, right,
Why not?
yeah, you got it. Okay, once you have them done, keep putting them up. Call me over if you want to check your work.
Is the area of a 180 done high?
It's pretty close. Right, because you're starting to see a pattern here. Yes. You guys don't have school. You guys don't have school. Yeah, the juniors have to come here for SAT. Sophomores could do a pre-ACT at home, I think. They did it from home. You guys don't have to do anything on Monday, right? No. Oh, yeah. SAT that coming early, yeah.
Didn't we already have an SAT for the end of the year?
The PSAT. This is the official SAT exam for those who it's hard to find available spots because it's on the computer now. And like large public schools that used to host it in paper don't have quite the bandwidth to handle so many laptops at once. Which is ironic because like our school, we're a smaller school, but we actually have much better infrastructure. So we actually could be a better place to host. So people like sometimes driving down to like Modesto or Sacramento or to take just to take the SAT because they can't find a spot in the Bay Area. So schools are offering it for their own students.
Like there was like a bunch of students who like took in San Francisco and like it was like a mess. Like
Yeah, so some if you do a hotel convention center and the Wi-Fi goes out, you're screwed. So you can't take tests that day. How old's your brother? Oh, okay. Well, 5, 6 years ago, I have several students who are flying to Idaho or Arizona because of COVID, because their COVID restrictions weren't as strict as ours. So anyhow. Okay, cool. Now we're just waiting on one more group. Yeah, let's do it. Sure. Yeah, ignore it. 'Cause Yeah, don't worry about it. I told him you're not doing it. Yeah. No, because it shows up on their end, but they don't know what it really means. Yeah. Okay. And any other people put up or anyone else wants to put you can put the octa, yeah, because yeah, Zoe, yeah, you need help. Can't keep it because Zoe's as well up.
Well, you can do that.
Right. Okay, cool. This is all looking really, really sharp. Okay. So you're noticing a pattern. Some of these numbers are a little off. Yeah. I think 1 for 6 is off for that one. But it's okay.
2 point.
You know, there's a little error. It's okay. Um, so what do you notice is happening as n gets larger, as I add more and more sides, right? What is the area approaching as n gets larger? Pi. Yep. And one thing you guys haven't learned yet, which you will learn in Algebra 2 next year and become more clear in pre-calculus, and in calculus becomes very, very clear, is something called a limit. There's a limit to our area, right? The area doesn't increase forever. Eventually, it tapers off. So as n approaches infinity, so when n's getting large, right? This is n, number of sides. As n gets large, what's the area approaching? Yeah, 3.14 pi, correct.
So would that be the same if the radius was 2?
No, then it would be quadrupled. It'd be 4 pi.
4 pi.
Correct. Right, because that's scale factors, right?
Yeah.
Yeah, so good.
It's looking like,
We are.
oh, we are?
Yeah. So I'll get through this. We'll be okay. Yeah. Yeah, we'll try to leave in about 10, 15 minutes, hopefully. Because we got another page of notes to do. Okay, the perimeter. What's the perimeter approaching? About 6.28, right? And of course, it's a little off in the beginning, but or 2 pi. Now, why does this matter? Because if you look at an octagon, or let's look at a pentagon first, right? Does the pentagon look circular? Not really. I mean, that's a terrible looking pentagon, but when I do an octagon, we know an octagon is not a circle. You know, we see stop signs all the time when we're driving, right? But that looks a little more circular, right? This right here looks very circular, right? So if we think about perimeter is going to be like circumference. You guys remember circumference of a circle? You guys seen that before, right? Or area of a circle. Do you guys know the formulas for these formulas for area and perimeter? Yeah, area is pi r squared, and perimeter is 2 pi r. Now, I get students that often confuse these. Like, well, I don't know which one's which, right? Because they're memorizing. First of all, area we know is a squared quantity, right? But secondly, because the radius is 1, if I plug in 1, that's going to be pi. If I put in 1 here, that's going to be 2 pi. And we saw for yourself, you did the work. I didn't do it. You guys did it. That as n gets large, the perimeter is counting all the sides. If you think about it, if you're walking around a circular track, or you're walking around some octagon or whatever, right? You walk around one revolution, you're walking 2 pi r, right? Or 2 pi whatever, inches or feet. The radius is different. I mean, so the area is different because that's pi r squared. So hopefully this helps you keep things clear. You don't confuse these. You see why area is pi r squared and perimeter is 2 pi r, right? Hopefully we can see that connection. Because ultimately these are starting to look more and more circular. And if I show you the true answers, here are the true answers. And feel free to if you copy what's on the board, it's all good. I mean, some of them are a little off. It's okay. Here are the true answers. You can see it steadily increases, but it eventually tapers off as we get to 180 sides. Okay, so move on to the next page. You got spot on? Yeah, that's fine. All right. So now, analysis of your data. What do you predict the area will be for a regular polygon infinitely many sides? Well, now we know pi r squared. What do you predict its perimeter will be? 2 pi r. Wasn't a name for a regular polygon with many sides, a circle. So you see the connection now with circles and polygons, right? So hopefully this all makes sense now. Like, see, I can go through this quickly because we did a lot of the hard work earlier on. What special ratio are we investigating today? Well, pi.
So I'm gonna erase the word.
Oh, yes, thank you.
Circles don't have sides.
They don't. But it's getting closer to it. You're assuming that. Now for pi, yeah. How many digits of the special ratio do you know? I'll be honest, I really don't know many. My old classroom, like many years ago, I actually had
9-2.
a banner that had showed all
6, 5.
159, 265, and that's the best I can do. Now, how many digits do you know? I'm just putting some. We are. Yeah, next week.
Wait, what do you treat?
Well, I haven't decided if we're doing a.
You make those cookies and then whoever wins gets some.
No, I gotta make pie instead. I could do cookies still. Yeah, let me talk to Mr. Davidson about that. I'll put something in Schoology. Well, I'd like to reserve a hearth and we could bake. That'd be fun.
You can bake pie.
Yeah, let me talk to Mr. Davidson about that. What's the pie song?
Pie song?
I don't know the pie song.
Serious?
I'm serious. I don't know it. It is very disappointing. I'm disappointed in myself. Okay, just it goes on forever, and there's no pattern.
Wait, aren't there still like people are like calculating it like day by day?
I know, right?
Crazy. Imagine that's your job.
So I would agree. I got very things to do with my time. We call this an irrational number, by the way, because it's not a ratio of two integers. That's another thing we'll talk about at a later time. But it's called an irrational number because there's no rhyme or reason to it. Like for example, 2/5 is 0.4, right? Or 1/3 is 0.3 repeating. This is kind of weird, right? So it is what it is. That's what pi is. We keep going. So let's the formulas now. So the area of a circle is pi r squared. Circumference is 2 pi r. Remember, area has to have square units. And we saw the area was 3.14, right? You saw that. So it should be pi r squared because the radius is 1. The circumference we saw, the perimeter was 2 pi r or 6.28, so it should be 2 pi r. What is the exact area of a circle with a radius of 1? Well, it's pi unit squared. And what's the exact circumference? 2 pi units. Okay. I do want to talk about the next page because Mr. Davis' class did do that. We'll stop after page 31 and then we can go outside. You guys can work. And homework, by the way, is homework 20. You guys have the pack. It's the last set in that packet, that thick homework packet that you guys have. So that will be the homework. You guys can get a head start when we go outside. But makes sense what's happening here. We're good. All right. So what is the relationship? So 8.3.2. And again, we'll wrap up 8.3.2 on Tuesday. Remember, we have no school Monday, so we have 2 days next week. In lesson 8.3.1, your class covered the area of a circle with a radius of 1 unit. There we go. And this comes 2 pi. But what if the radius is different? What if it's 5 or 13.6 or whatever? So let's develop a method to find it if the radius is not 1, blah, 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 whatever. So here we go. We know the area is pi r squared. Circumference is 2 pi r. So this is easy. That's pi and 2 pi. So what do you guys think is happening when radius is 3? 9 pi. 25 pi. 64 pi. 81 pi. And of course, pi r squared. Or r squared. We'll just say pi r squared. And that would be 2 pi r. Now here, this just scales up appropriately. That's 6 pi, 10 pi, 16 pi, 18 pi, and so forth.
Wait, why is it the square roots for each of those things?
The squares, because that's the formula, pi r squared. Yeah, and square, not square root. Careful what the words we use, right? So the other thing that we'll notice too, these are all similar, right? Like 1 to 3, 1 to 3 ratio, right? Or like that's 1 to 8 ratio, 1 to 8 ratio. The areas don't follow that. You have to square the scale factor to get the new area. So let's move on. Well, actually, I'll wait for everyone to get caught up. Okay. So since circles always have the same shape, what's the relation between any two circles? They're always similar, correct? So we call these concentric circles, circles that share the same center. And so forth, right? So the ratio of their circumferences or perimeters would be a to b. The ratio of the areas would be a squared to b squared. Okay, and I think this would be a good place to stop for today. So homework will be this. You guys can get a head start as we head out. And I do ask that we head out that way, just the quickest way so we're not disrupting other classes. But I want you guys being productive though. Try to get some work done. I know it's nice outside. You can socialize a little bit, but yes, Zoe, good. And actually, yeah, you might need to take the elevator. So sorry. Can someone help Zoe out? Okay.
Where are we going?
Just a grassy area, like the amphitheater area, right in front of Campbell. Just beautiful out there. Yeah, homework 20 is right here. Just a bunch of circle problems. So yeah.